couple more log problems here, and then the same way we rewrote these up here, 16 to the what power equals 1, 2 to the what power equals 1 over 64. We're going to do that here. 7 to the second power, 7 to that power equals this other thing, 2x minus 11. So whereas this one here we could ignore the log, because if we had the log of this equal to the log of that, well, this has to equal that. Here, it's not as cut and dry. You need to know your transformation from logarithm to exponential, and that's what that is. 7 to the second power equals this. Well, that's 49. Now it's just a matter of simplifying. Equals 2x minus 11. You add the 11 to both sides. You get a 60 equals 2x. You divide by 2, and you get x equals 30. This is a similar problem to that last one, but the difference is we have two logarithms that we have to combine together. And when we add logarithms, that means we're multiplying the argument. It becomes log base 2 of 4x squared, and that's equal to 4. It is now that we apply that same step from before where we did the base to the power equals the solution. Base 2 power 4 equals 4x squared. 2 to the 4th power, we've been through 2 to the powers today, some successfully and some otherwise. 2 to the 4th is equal to 16, so I got a 16 equals 4x squared. Divide by 4, and I get a 4 equals x squared, and technically that gives me an x equals plus or minus 2 if I take the square root. However, only one solution makes me think, well, why would there only be one if I've got a plus or minus? Well, it turns out you can't take the log of a negative, so the answer is only the positive, which means if you forgot the negative, worked out for you because you got it right anyway.